Okay, so here we're going to be multiplying two matrices together. We already looked at scalar multiplication, where you're just simply taking a number, the scalar, and multiplying it by each element of the matrix, right? Now we are looking at a second type of multiplication known as just matrix multiplication. And it's not as easy as you might think it would be. Okay? Addition and subtraction between two matrices was really simple. Just add or subtract the corresponding elements. That's not how it works for matrix multiplication. Okay? So here's the rule. You can multiply two matrices if and only if the number of columns in the first matrix equals the number of rows in the second matrix. Okay? All right, so let's say we're working with matrix A, and it has dimensions 3 by 4. So that's 3 rows by 4 columns, right? Matrix B has dimensions 4 by 2, 4 rows by 2 columns. If I want to find the product of A and B, I need to make sure the number of columns for matrix A represents the number of rows for matrix B, which here it does. There are 4 columns in matrix A. There are 4 rows in matrix B. Those are equal to each other. Okay? If those were not equal to each other, we'd say the product is undefined. Okay? Now, with the product being defined here, we can use the outer two numbers, so the number of rows from matrix A and the number of columns for matrix B, those are the numbers you see in blue here. Those will come together to give you the dimensions of the product matrix. So this product matrix would be a 3 by 2. And that's really important to know because it tells you how many elements you're after. Okay? Mr. Widow wants to share a website with me.
I keep getting that too. Yeah, it's like an extra. Yeah.
Goodness gracious. I'm going to just decline. Okay. It's an extra credit geometry assignment.
Yeah, I'm not even in geometry.
I wonder if he's just airdropping the whole hallway maybe. I don't know. Okay. So let's see how this works. I want to find the product of K and L for the given matrices here. So what are the dimensions of matrix K? Anybody? I heard 2 by 3 and I heard a 3 by 2. That is a 3 by 2. Remember, rows are horizontal, columns are vertical. You always do rows by columns. Okay? What are the dimensions of matrix L? 2 by 3. Okay, so if we're finding the product KL, I need to make sure the number of columns of K, the first matrix, equals the number of rows of matrix L, which it does. These are equal. So that means the product is defined, right? What are the dimensions of the new matrix? 3 by 3. So there's going to be 9 total elements to find here. Okay? All right, now, positioning of the element that you're trying to find is extremely important here. All right? So let's focus on the first row, first column element. Notice how I'm saying that. First row, first column element. So that's this one right here. Okay? To find it, I'm simply going to use first row elements of K and first column elements from L. And here's the calculations. I take 1, I multiply it by -3. I add that with -2 multiplied by -1. So pause and notice the orientation here. So I started with the leftmost number of that first row, and I multiplied it by the topmost number of the first column in the second matrix. And then I just worked from left to right and top to bottom. Okay? All right, now that's going to give you -3 plus 2 or -1. So our first row, first column element ends up being a -1. Let's put that down here. Any questions on that? So I think that's interesting because notice while this is matrix multiplication, it actually requires some addition. Okay? All right, now let's go after first row, second column. First row, second column. I use the first row elements of K, but now I use the second column elements of L. Process is still the same though. I start with the leftmost number and the topmost number. So it's going to be 1 multiplied by 2 added with -2 multiplied by -2. So that's going to be 2 plus 4 or 6. And now we're after first row, third column element. So I continue using the first row of K, but now I move to the third column of L. I take 1 multiplied by 2 plus -2 multiplied by 0. That gives me 2 plus 0 or 2. So I've completed all of the first row elements of this product matrix. Questions so far? All right, now notice you've exhausted the first row of K with every column of matrix L. So you're done with the first row of K, and now we can move to the second row of K. So let's go after second row, first column. All right. I would do 4 multiplied by -3 plus 3 multiplied by -1. That's going to be -12 plus -3, so -15. And then we'll move to second row, second column. Calculations are 4 times 2 added with 3 times -2. That would be 8 plus -6 or 2. Okay. And then we move to second row, third column. 4 times 2 added with 3 times 0. That's just going to give you 8, right? Two-thirds of the way there. Okay, so now we move to the third row of K. Let's go third row, first column. I'm going to do 0 times -3 plus -1 times -1. That's going to be 0 plus 1 or 1. Okay, and then we move to third row, second column, 0 times 2 plus negative 1 times negative 2. So that ends up being 0 plus 2 or 2. And finally, third row, third column. 0 times 2 plus negative 1 times 0. That's, of course, going to give you 0 plus 0 or 0. And there is our product matrix. Any questions on the process? Okay, go to example 2. All right, now I'm using the same two matrices, K and L, but this time I want to find matrix LK. LK. So what we want to see here is whether or not this result is going to be the same as what we just found, right? And we'll see very quickly whether it is or not. Okay, so once again, dimensions for K are 3 by 2. Dimensions for L are 2 by 3. This time if I'm multiplying L with K, L's the first matrix, so I need to look at the number of columns in L, which is 3, and that's got to match the number of rows in K, which is also 3. Those are equal, products defined, right? What are the dimensions then of the new one? 2 by 2. So right there, we can already kind of see that we're not going to get the same result, right? Before we got a 3 by 3, here we're getting a 2 by 2. So I have a note down here at the bottom. KL doesn't end up equaling LK, thus the commutative property does not hold true for matrix multiplication. Mia, did that ever open up for you? No? You want me to airdrop them to you? You sure? Okay. Okay, now I bring this up because if you recall, when we did matrix addition, we looked at a couple properties of real numbers that held true for matrix addition. So we had the commutative property and the associative property. Those held true for matrix addition. Okay? And also the distributive property held true for scalar multiplication and matrix addition. So this is like the one real number property that's not holding true for matrices right now. Okay? All right, so let's go and find the elements here. So first row, first column. I need the first row elements of the first matrix. So that would be L, and the first column elements of the second matrix, K. And again, I go left to right and top to bottom. So I'm going to do negative 3 multiplied by 1 plus 2 multiplied by 4 plus 2 multiplied by 0, or 0 multiplied by 2. That's going to be negative 3 plus 8 plus 0, or 5. Okay, now let's go after first row, second column. So I'm moving to here. I'll take negative 3 multiplied by negative 2 plus 2 multiplied by 3 plus 2 multiplied by negative 1. So that's 6 plus 6 minus 2, or 10. And now I'm done with the first row of L. I can now move to the second row, and let's move this back to the first column. So this is going to give me the second row, first column element. Let's do -1 times 1 plus -2 times 4 plus 0 times 0. It's -1 minus 8 plus 0, or -9. And then we move to the second column of K. -1 times -2 plus -2 times 3 plus -1 times 0. That's 2 minus 6 plus 0, so I'm getting a -4. Apparently they're getting Mr. Widow's airdrop too. All right, when you're ready, click over to practice 1. So I have matrix M and matrix N. Matrix M is a 2 by 3. Matrix N is a 3 by 2. Will the product of M and N be defined? Absolutely, because these two numbers are the same, right? And the dimensions of it will be a 2 by 2. Now, I already have half of it figured out for you. Take a few minutes, see if you can get the missing 2 elements. What on earth are you airdropping us for? I got it on my iPad, my phone.
I'm literally airdropping nothing, and that's a file I don't have.
It's a turkey, what's that called, virus?
You've been hacked.
I must have been hacked.
Yeah.
Oh,
I'm
interesting.
not talking COVID virus, I'm talking computer virus.
Yeah.
Yes.
Give you one more minute. All right, Kyle, what'd you come up with for that first row, first column spot?
2.
Positive 2. How's the room feel? Good? All right, let's verify it for those that are going to be watching this at home. That's first row, first column. So we're using these numbers with these, right? We're taking negative 1 times negative 2 plus 2. Oh, my pen just died. Give me a second here. Plus 2 times 0. Sorry, this writing is going to be really bad. Plus 0 times negative 3. That's going to be 2 plus 0 plus 0, which is, of course, 2. Okay, let me try this, actually. All right, who's got the second row, second column element? Kara, what'd you come up with? 14? Agree? Okay, so for that one, it would be this row with this row. You'd have negative 3 times 4. That's negative 12. Plus 5 times 6. That's 30. Plus negative 2 times 2. So that's negative 4. Negative 12 plus 30. That would be 18. 18 plus negative 4 would be 14. Sweet.